So next I'm going to show you how to use CFG LCK and the auth lim. CFG LCK means configuration lock. So using this bit, it's a bit value where you can have 0, 1 writable and 1 is locked. So if you set this as locked, we cannot change the values of the CFG 0 and CFG 1 pages. That means whatever configuration values we have set here, they are fixed and we can't change it in future. Auth lim means it's a authentication limited, something like that. So you can control how many times we can let user do the wrong password authentication. So if the value is 0, there is no limit. User can try breaking the password or try any password, and the system will accept any number of failures. Or assume that we want to limit the number of times user can put the wrong password. If I set this to 3 or say 5, so the system allows user to enter the wrong password 5 times. If the 6th time is also wrong, the user is prevented from using whatever operation is set to the prot. So for example, if the prot says write, then after the 6th unsuccessful authentication, the system will prevent somebody writing to all the protected pages. And if the prot was set to read and write, and after again 6th negative authentication, you cannot read and write at all. So to understand this, the documentation has got some good information. So as you can see here, the CLK is available in the access byte is over here, and auth lim. So the auth lim has a 3-bit value. If you scroll down here, so the auth lim is a 3-bit value, so you can go up to 0 to 7, or in other words, you got 8 negative attempts is allowed. Similarly, the CFG LCK is a 1-bit value, so the documentation says if the value is 0, you can write to the configuration or change the configuration. If the value is 1, it's locked from writing. And here also you can see that when all the 3 bits are zeros, limiting of negative pass verification attempts disabled, and any value from 1 to 7, so it says maximum number of negative password verification attempts. So to try this, you have to be very careful, because if you try auth lim, if you forcibly make it trigger, you cannot use this card again. So however, I'm going to try that, and later I'm going to bin the card. So I'm going to set the auth lim to 3. I'm also going to set the password protection from page number 10 onwards. 10. I'm going to first enable the password, and the negative auth set to 3, and the prot is right. So what I've done is I need to authenticate before I write from page number 10 onwards, and the negative authentication limit is set to 3, and I'm going to write this, and also going to lock the configuration so that I can't do any more changes at all. So right, so that's it. The configuration is completely locked forever. You cannot undo this operation. So let's try to break this card now. So I'm going to bin this soon. So how do you break? So we have set auth lim to 3. So I'm going to stop and start all again. I can read, no problem, because there's no password authentication for reading. So let us try to write for page number 10. I'm going to fail more than 3 times. So let us make our password intentionally wrong. Say 1 2 3 3, which is wrong, I know that. Say authenticate, or it's failed. So start again. Go. I'm going to authenticate again. Yeah, authenticate, again failed. So remember, we missed twice. Stop. Every time you get an error from the card, you have to start all over again. So authenticate, just check with wrong password here. We want the wrong authenticate. So we failed 3 times. Stop again. So we'll fail the last time. I think it's more than 3. Just try, or just try to make it, see if it works for 3. So 1 2 3 authenticate. Yeah, so authenticate is successful. So can I write, can I change, just change this page number 10 to all B's, right? Okay, so 3 is allowed. I think more than 3 is not allowed. So let's go back and do that again. So change the password to 3, authenticate, failed, stop, start again, authenticate, failed, stop, select again. So authenticate, failed, we have failed 3 times, stop and start again, and authenticate, 4th time we have failed, stop, select again. So not here. Okay, so this time I'm going to authenticate with the correct password 1 2 3 4 and set this as authenticate. It failed. So we have broken this NTAG 210. It is because auth lim was set to 3 and we were wrong 4 times. So that's it. This tag 210 will go to the bin now. The other thing which I have not discussed in this video is called a static locking, which is very similar to the static locking right from ultralight and NTAG 203. So request you to see the videos on those tags. And that's it. Next I'm going to show you the structure of NTAG 212. NTAG 212 is not easily available to buy from internet. However, I have got few tents with me so that whoever buys the box will get a chance to play with NTAG 212. I'm not going to go in detail because NTAG 210 and 212 are exactly have the same structure. The only difference is because NTAG 212 has got more memory, it has got a dynamic locking to lock memory pages which is more than 16. So NTAG 212, what I have here is a tiny sticker. So I'm going to connect and click on select. So go to the last tab and click on go. So as you can see here, NTAG 212 has got 41 pages altogether, and because this is a new card, you can see that the locking bits are zeros, the static locking bits zeros, and you got everywhere you got some default values. So if you click on the password and configuration, which is exactly the same as NTAG 210, and we know already in the previous videos, the locking, we have got 2 lockings here. The static locking, which is very similar to the ultralight or NTAG 202, and we got the dynamic locking, which I'm going to discuss in detail. In the version signature tabs, you can see NTAG 212 has got a different value for the storage size, which is 03, and this is the 32-bit ECC signature for NTAG 212. If you go to page number 12 in the original documentation of NTAG 212, there is a explanation about the structure of the dynamic locking. So as you can see here, the dynamic locking bits are present in page number 36, and it uses 3 bytes, the byte 0, byte 1 and byte 2, and byte 3 is not used. So each bit of the dynamic locking locks certain number of pages. In case of 212, each bit locks 2 pages. As you can see here, the bit 7 when it's set to 1 locks the page number 30 and 31. Likewise, the bit 6 locks page number 28 and 29. So similarly, if you take one more example, like the bit 0 of the byte number 1 locks the page 32 and 33. All these locks that starts with the letter BL, it means the block locking. So this bit are used to lock the lock itself. Take for example the BL3235. When this bit 4 is set to 1, we cannot change the lock bits that corresponds to 32 and 35. That is, those two are here, the 32 to 35. So these two lock bits cannot be set or cannot be changed. So we take one more example. For example, the BL2427. So when this bit is set to 0, so this will prevent anyone from locking these two bits 24 to 27. So you cannot lock these two bits when the BL2427 is set to 1.